Model A 50 features, 82% accuracy. Model B 12 features, 86%. Fewer inputs, higher score, same dataset. That shouldn't be possible. So how? Episode 21, Feature Selection. Why fewer, better chosen features beat throwing everything at the model. More features sounds like more information. It isn't always. Some features are just noise, they add nothing but confusion.
Some are near duplicates of each other, saying the same thing twice.
Some fight each other for credit and the model gets unstable. More columns also means slower training and a bigger overfitting risk.
Feature selection prunes all of that before the model ever trains.
First technique, correlation filtering. Two features with a correlation above 0.9 are basically twins.
Keep one, drop the other. You lose almost no information.
A heat map makes these pairs jump out instantly. This alone can remove a surprising chunk of a bloated dataset. Let's prune a real feature set, live start to finish. 20 features. Correlation heat map first.
For pairs are near duplicates. Drop one from each pair.
16 features left. Now the VIF check.
Two features are fighting each other for credit. Drop the weaker one.
14 left. Now RFE removes the weakest feature one at a time.
Down to 12. Lean, uncorrelated, and every one of them earns its place.
Recursive Feature Elimination, or RFE. Train the model. Rank every feature by importance.
Drop the single weakest one. Retrain. Rank again. Drop the weakest one again.
Repeat until you hit the feature count you asked for. It's slower than a correlation filter, but it's model-aware. Multicollinearity is when features overlap so much the model gets confused. VIF, variance inflation factor, measures exactly how confused.
VIF above 10? That feature is mostly explained by the others.
It doesn't add new information. It just adds instability. Drop it or combine it with the feature it overlaps with. In code, all three techniques stack together. Correlation filter first. Drop the obvious duplicates. VIF check second. Drop anything still fighting for credit.
RFE last. Prune down to your target feature count. 3 filters, 1 lean feature set.
If this is clicking subscribe. ML pipelines is next. Same model, same dataset, 2 different feature counts. All 50 features, no selection at all. 82% accuracy. After correlation filtering, VIF and RFE just 12 features.
Accuracy, 86%. The model didn't gain information. It lost noise.
A few mistakes come up constantly here.
Running RFE on the full dataset before splitting, that's a leak.
Dropping features by correlation with the target alone, that can miss interactions. Chasing a fixed feature count instead of watching cross_val_score. Selecting features once, then never rechecking after new data arrives.
Every one of these turns a clean prune into a silent bug.
So which technique when?
Lots of near-duplicate features. Start with correlation filtering. It's cheap.
Suspect features are fighting each other, run a VIF check. Need the model's own opinion on what matters, RFE. Huge feature count, tight compute budget, filter first, RFE on what's left.
Whatever you choose, select features inside cross-validation, not before it.
Quick recap before we go.
The problem: more features can mean more noise, not more signal.
Correlation filtering, drop near-duplicate features. VIF, drop features that are mostly explained by the others. RFE, let the model rank features, then prune the weakest repeatedly.
And always select features inside your cross-validation loop.
Where we are in the series, we can prepare data, balance classes, and now trim it down to what matters.
Episode 22, Building ML Pipelines.
Turning everything so far into one reusable object, start to finish. Episode 22, Building ML Pipelines explained. Why raw notebooks quietly break the moment they hit production.
Pipeline and column transformer, wired together properly.
One object, raw data in, a prediction out. Subscribe so you don't miss it.
Your challenge task for this episode.
Take any dataset with 20 or more features. Build a correlation heat map. Drop one from every highly correlated pair. Run a VIF check on what's left. Drop anything above 10. Run RFE with a simple model down to your final feature count.
Compare full feature set versus your pruned one.
Bonus. Plot accuracy against feature count as RFE removes columns. Solution is in the repo. Think before you look. Model A 50 features. Model B 12.
Model B didn't have more information.
It had less noise. That's the whole 4-point gain.
Episode 22, Building ML Pipelines, drops next. Subscribe. Comment below. What's the most features you've ever thrown at a model?